At this very moment, as you read these words, a remarkable event is unfolding far beyond Earth's reach, yet almost no one knows it's happening. A spacecraft no larger than a compact car is traveling through a region of space that humanity has never explored. No astronaut has ever seen it, no probe has ever ventured there before, and no scientific theory has perfectly predicted what exists in this mysterious frontier. What makes this even more incredible is that this isn't some cutting-edge spacecraft built with today's technology. It was designed long before the internet became part of daily life, before personal computers sat in people's homes, and before many of the scientists now studying its transmissions had even been born. Even more astonishing, it operates using only about 4 watts of power. That's less electricity than the tiny bulb glowing inside most refrigerators. Yet this aging spacecraft, small, underpowered, and originally expected to survive for only 5 years, is still sending back information that is forcing scientists to rethink some of their biggest assumptions about the universe. The experts analyzing its discoveries aren't describing them as merely interesting or surprising. Instead, they're using words like astonishing, puzzling, and even admitting we got it wrong. This is the incredible journey of Voyager 1. But here's the part you rarely hear about. The most unsettling discovery isn't simply what Voyager 1 found millions of miles away, it's that those discoveries may have direct consequences for life here on Earth. Even more intriguing is what's happening to the spacecraft right now in 2026, a development that has received surprisingly little attention. And in just a few months, a milestone already marked on scientists' calendars will take place, representing a moment humanity has never experienced before. Stay with me until the end, because once you understand this story, you'll never look at the stars above you in quite the same way again. I'm your name, and you're watching your channel. If you enjoy fascinating stories about space, science, and the mysteries of our universe, be sure to subscribe, because we're only getting started. Let's rewind to where it all began. September 5th, 1977. A rocket rises into the Florida sky from Kennedy Space Center, carrying a spacecraft known as Voyager 1. The mission itself seemed straightforward. Fly past Jupiter, continue to Saturn, capture images, gather scientific measurements, and then quietly drift into the darkness of space. NASA expected the spacecraft to function for about 4 years, 5 if everything went exceptionally well. By the early 1980s, the mission would likely be over. It would leave behind a valuable collection of photographs and data from the outer planets before falling silent forever. But history had something entirely different planned. Voyager 1 never stopped. In March 1979, it swept past Jupiter, returning breathtaking close-up views unlike anything humanity had ever witnessed. Then, in November 1980, it reached Saturn. Instead of slowing down, it used each giant planet's gravity like a cosmic slingshot, gaining even more speed as it continued its journey deeper into space. As the 1980s came to an end, Voyager 1 had already become the most distant human-made object ever created. Against all expectations, it continued to function, continuing to transmit faint radio signals across an ever-growing ocean of space. It kept collecting scientific data using technology so old that modern engineers often find it difficult to believe it's still operational. Then, 35 years after launch, everything changed. In 2012, Voyager 1 crossed a boundary known as the heliopause. If that term sounds unfamiliar, it represents one of the most significant borders in our cosmic neighborhood. Crossing it was, in many ways, like stepping beyond the edge of humanity's home for the very first time. To understand why, imagine this. The sun doesn't simply provide warmth and light. Every second, it releases an endless stream of charged particles called the solar wind. These particles race outward in every direction, creating an enormous protective bubble that surrounds our entire solar system. Inside that bubble are all the planets, every moon, asteroid, comet, every spacecraft humanity has ever launched, and every living creature that has ever existed. Eventually, however, the solar wind loses its strength. At an immense distance from the sun, it collides with the pressure of interstellar space, pushing inward from beyond. The invisible frontier where those two forces meet is called the heliopause. In simple terms, it's the true outer boundary of the sun's protective influence. Everything inside belongs to our solar system. Everything beyond it belongs to the vast expanse between the stars. In 2012, Voyager 1 crossed that invisible frontier. It became the first human-made object ever to enter interstellar space. Not symbolically, not technically, physically. For the first time in history, something built by human hands had traveled beyond our sun's protective bubble and entered the ancient darkness, separating one star system from another. And incredibly, it kept talking to us. Think about what that really means. Right now, humanity has a functioning scientific instrument operating in interstellar space. It's not orbiting a planet. It's not cruising through the outer reaches of our solar system. It has gone beyond all of that, into a region no human has ever visited and no telescope can directly experience from the inside. This silent explorer is sending home measurements from one of the least understood places in the universe, a place that scientists could previously only imagine through theories and computer models. For the very first time, humanity isn't just wondering what interstellar space is like. We're receiving the answer directly from it. And what Voyager 1 has been revealing is nothing like scientists expected to find. This is where the story takes its first truly unexpected turn. For decades, researchers had carefully developed sophisticated mathematical models to predict what interstellar space should be like. These weren't rough estimates or educated guesses. They were built through years of peer-reviewed research, advanced physics, and countless observations by some of the world's leading scientists. Despite being created independently, those models painted almost the same picture. The vast region between stars was believed to be calm, a thin, freezing expanse where particles drifted quietly through nearly empty space. It was imagined as a peaceful cosmic void, a silent passage separating one star system from another. Then Voyager 1 arrived. Instead of finding stillness, it discovered a place filled with activity. Beginning in 2017, Voyager 1's plasma wave instrument started detecting something completely unforeseen. It picked up a steady, narrow-band signal, a faint but continuous vibration moving through interstellar plasma. According to every existing model, that signal simply shouldn't have existed in the way it did. This wasn't a brief pulse or a random burst that engineers could dismiss as faulty equipment. The mysterious hum remained constant, year after year, stretching across more than 900 million miles of interstellar space. To appreciate that scale, remember that Earth is about 93 million miles from the Sun. This strange emission extended across a region nearly 10 times that distance. When scientists analyzed the findings and published them in the journal Nature Astronomy, their conclusion was unmistakable. Interstellar space isn't the smooth, quiet emptiness we once imagined. It's restless, it's structured, it's filled with movement on every scale. from tiny variations measured in meters to enormous patterns spanning millions of miles. In other words, the space between the stars is far more dynamic than anyone realized. For the first time in history, humanity wasn't relying on telescopes or computer simulations. We finally had an instrument experiencing that environment firsthand. Pause for a moment and think about what that means. Everything we believed about the region beyond our solar system had been built from a distant viewpoint here on Earth, using equations, observations, and theoretical models. Now, the first spacecraft ever to actually enter that environment is telling us something astonishing. Our understanding was incomplete. The universe beyond the Sun is richer, more active, and far more complicated than our best predictions suggested. But here's where this story stops being a distant scientific mystery and becomes something that concerns every person on Earth. Because what Voyager 1 is discovering doesn't stay out in deep space. It connects directly to us. The giant bubble surrounding our solar system, the heliosphere, is more than just a scientific boundary. It serves as Earth's protective shield. It helps block enormous amounts of dangerous cosmic radiation, including high-energy particles produced by exploding stars across our galaxy. Without that protection, far more of this radiation would penetrate the inner solar system. If the shield is weaker or behaves differently than scientists have believed, the consequences for life on Earth could be significant. Voyager 1 is now showing that the interstellar environment pressing against that protective bubble is far more turbulent, energetic, and unpredictable than previous models had indicated. Scientists still don't know exactly how those conditions influence the heliosphere over long periods of time. But the fact that this question even exists marks a profound shift in our understanding of Earth's place in the universe and how protected we truly are. And then, the story became even stranger. Before we talk about what Voyager 1 discovered at the very edge of the solar system, we have to jump ahead to 2023, because that year, the mission came dangerously close to ending forever. For 5 long months, Voyager 1 continued sending radio signals back to Earth. The connection itself hadn't been lost, but the information arriving wasn't understandable. Instead of scientific measurements, engineers received corrupted data, scrambled code, and meaningless digital noise. The spacecraft was clearly alive. It was still talking. But no one could understand what it was trying to say. For the engineers at NASA's Jet Propulsion Laboratory, many of whom had spent decades working with Voyager, this was unlike anything they had experienced before. Eventually, after months of investigation, they uncovered the cause. It came down to one tiny component. A single memory chip inside Voyager's flight data system had slowly deteriorated after nearly half a century of non-stop exposure to the harsh radiation of deep space. That tiny piece of electronics, built with 1970s technology and only fractions of an inch across, had begun corrupting the software responsible for organizing and transmitting the spacecraft's scientific information. There had been no warning, no emergency signal, no dramatic system failure. After 46 years of faithful operation, the chip had simply reached its limit. Under normal circumstances, replacing a failed electronic part is straightforward. You walk over to the machine, open it, swap the damaged component. Problem solved. But Voyager 1 wasn't sitting inside a laboratory. It was more than 15 billion miles from Earth, far beyond the reach of any spacecraft humanity could launch. There was no rescue mission, no repair crew, no possibility of physically touching it again. The only connection between Earth and Voyager was a beam of radio waves traveling at the speed of light. Even that came with an incredible delay. Every command required 22 hours to reach the spacecraft. Then another 22 hours before a response could make the journey back. Every test, every diagnosis, every possible solution required at least 44 hours for a single cycle of communication. Imagine trying to repair the most distant machine humanity has ever built under those conditions. You examine the latest data, you develop a theory, you carefully write instructions to test that idea, you transmit the command, and then you wait. 22 hours. The spacecraft responds. You examine every bit of information it sends back. You compare it with your expectations and realize something doesn't quite fit. A new hypothesis begins to take shape. Another set of commands is carefully written and transmitted across the darkness of space. Then, you wait another 22 hours. The reply finally arrives. You study it, revise your understanding, create another solution, and send another command. Again, another 22-hour wait. This cycle repeated over and over for months. Every single decision carried enormous weight because the engineers knew one painful truth. A single incorrect command, transmitted only once across 15 billion miles of empty space, could permanently silence Voyager 1 forever. There would be no second chance. Inside NASA's Jet Propulsion Laboratory, engineers approached the challenge with extraordinary patience and precision. It was unlike almost any engineering problem in history. Eventually, they discovered something remarkable. The damaged software couldn't truly be repaired, but it could be moved. Instead of relying on the failing section of memory, the team divided the corrupted program into smaller pieces and relocated those pieces into healthy areas of the spacecraft's remaining memory. Every section had to be individually rewritten, carefully tested, and then reconnected so the entire system could function as one again. Imagine performing delicate brain surgery on a machine nearly 50 years old, located 15 billion miles away, while every conversation with your patient takes 44 hours. That is essentially what they accomplished. Then, in the middle of 2024, the impossible happened. Voyager 1 came back. Its transmissions were once again clear, complete, and scientifically useful. Almost immediately, the spacecraft resumed sending fresh observations from interstellar space. Among them were even more measurements confirming those mysterious plasma oscillations, the same unexplained signals that had already challenged decades of scientific predictions. The spacecraft that was expected to stop working in the early 1980s had survived yet another crisis, and it still had new secrets to share. But even those discoveries, even the near loss of the mission, even its astonishing recovery, none of it prepared scientists for what Voyager 1 had actually encountered when it crossed the heliopause back in 2012. Because this is where the story becomes truly extraordinary. Reading the scientific papers describing that moment, the language begins to feel less like ordinary physics and more like something almost unbelievable. For years, researchers believed they understood what crossing the heliopause would look like. As Voyager approached the boundary, the solar wind inside the sun's protective bubble would slowly weaken, while the interstellar medium outside would gradually become stronger. The transition was expected to be smooth and gentle, like fresh water slowly blending into the ocean. Reality turned out to be completely different. Instead of a calm transition, Voyager encountered particles moving at extraordinary speeds, some traveling at a significant fraction of the speed of light. These particles collided with incredible energy, creating temperatures approaching 30,000 degrees Celsius, not inside a star, not near the Sun, but at the outer edge of our own solar system, in a region scientists had long believed to be relatively cold and quiet. Some researchers have even referred to this region as a wall of fire, not as poetic imagery, but as a real concentration of extremely energetic charged particles forming a powerful barrier at the boundary of our solar system. And that wasn't the only surprise. There was also the mystery of the magnetic fields. For decades, scientists expected Voyager to observe a dramatic magnetic shift after crossing the heliopause. Inside the heliosphere, the spacecraft should detect the Sun's magnetic field. Outside, it should encounter the entirely different magnetic field of our galaxy. Two separate environments, two distinct magnetic systems, a clear dividing line between them. But Voyager 1 didn't see that. Instead, it revealed that the magnetic fields on both sides of the boundary were linked in ways existing theories had failed to predict. The Sun's magnetic field, carried outward by the solar wind, was interacting with the magnetic field of interstellar space through a process known as magnetic reconnection. During this process, magnetic field lines from different regions break apart, reconnect, and release enormous amounts of energy. The implication was profound. Voyager 1 revealed something extraordinary. Our solar system is not completely isolated from the galaxy. At the edge of the heliosphere, energy and magnetic fields are constantly interacting with interstellar space, forcing scientists to rethink how our cosmic shield protects Earth. But Voyager's journey is entering its final chapter. Powered by aging plutonium generators, the spacecraft's energy supply continues to decline. Since launch in 1977, its power has dropped from about 470 watts to nearly half that amount. Engineers are slowly shutting down instruments to keep the mission alive as long as possible. Yet Voyager is still making history. Its mysterious plasma signals are giving humanity the first continuous view of interstellar space, revealing that the area between stars is not empty, but active, structured, and filled with cosmic activity. The biggest mystery remains unsolved. Scientists still don't know exactly what creates these signals, and when Voyager finally loses power in the coming years, humanity may have to wait decades before another spacecraft can continue the search. But Voyager will keep traveling, carrying the golden record, a message from Earth to the unknown. It will drift through the galaxy long after its final signal reaches us. A nearly 50-year-old machine, built before modern computers existed, powered by only a few watts. Yet it is still teaching us about the universe. One spacecraft, one final connection to the stars. The question is, are we still listening?